This lesson is on indefinite integrals, mainly focusing on these formulas here. It's a bit of a recap of year 11 methods and some of the stuff that you guys would have done last year. But let's have a look at these rules. It's the same thing really. One's the VCAR exam formula sheet and one's just our little version there, but they're meaning the same thing. Basically, if we have a function with any of these forms, so x to the power n, or x to the power anything really, we add 1 to the power and then divide by that new power. It looks a bit confusing in that form, so let's have a look at some examples. So for example 1a, if we're finding the integral of 2x to the power 7, we would add 1 to our power, giving us 8, and divide everything by our new power, which is 8. And of course that gives us 1 over 4 x to the power 8. Plus c, we always need that constant, as we don't know what that point is until we use substitution of a point on that function to find out what c is, which we'll do a little bit later. Part B, -3 plus 1 is -2. So 4 divided by our new power is -2, giving us -2 all over x squared. So writing it as a positive power is always a good idea. For example C, my first step is to expand my brackets, making it a bit easier to work with. Once again, adding 1 to our power, giving us 3. So 3 over 3 squared, 2 over 2, and any constant like this, the -5, just becomes -5x, and that's just going to be a 1, so we don't really focus on that at all. X squared there, and -5. There we go. For example D, I've divided both my numerator terms by x squared, giving us 6 plus 5x to the power -2, and again a constant 6 will just become 6x, adding 1 to our power, giving us 5 over -1, and that is of course plus 5 over x with that positive power. Example 2, find the equation of the curve gx, given that g dash of x equals 3 square root x plus 2, and it goes through the point 1, 2. First step is to find the integral for this. So if we work this out, so a half plus 1 becomes 3 over 2, and this is a little confusing. This becomes 3 over 2, which is the same as multiplying by 2 and dividing by 3. So that will just give us 2 as our final solution there, and this will become 2x. Write that out in a bit more detail if you're a bit confused about that, but 3 divided by 3 over 2 is the same as multiplying by 2 and dividing by 3, just using our flip and multiply setup. We can then sub our point in, so 1, 2 into this equation. So 2 is my y value, 1 is my x value, and that's going to give us 2 plus c. And of course that gives us c equals -2. Rewriting my function, it did ask us to state the equation of g of x, as I've done there. This final problem is a little advanced for what we're doing here. This is really looking at area under a curve, but let's have a go at it now so you can see what you're working towards. Our first step is to change 1 over the square root of x to x to the power -1 over 2, and then the integral for that, of course, is going to be x to the half divided by 1 over 2, and that just becomes 2 square root x. What these 4 and 1 values mean is we start subbing those in, starting with the 4 and then the 1, and this is finding the area under the curve between those two values. Subbing them in for x, I should say. So 2 square root 4 and 2 square root 1, which becomes 4 minus 2, which is just 2 as a final answer. So we haven't really covered much of that in this lesson, but give that a go. That's the kind of end point of what we're working towards with these integrals.